So x and y aren't relating to each other directly. They're all talking through like this intermediary, this t. That's a parametric equation. So if you need to know what the graph looks like this says to graph the curve, you can make a three column table, choose whatever value you want to plug in for t, and see what it spits out for x and y. So I can plug in t equals 0, and if I do that, I get x is 0 and y is 0. That means the graph of this relationship, it's a regular x and y grid. It's got a dot at 0, comma 0. If I plug in 1, then I get 1 for x and 1 for y. So there's our dot right there. And I don't want to plug in 2 because I'll get square root of 2. Let's plug in 4 for t. Square root of 4 is 2, and then y is 4. That's probably enough to get the idea. Maybe if we plug in t equals 9, the next we're going to get 3, y, we're going to get 9, because if I plug in 9 in here, I get y equals 9. So at 2, we're at 4 for the y-axis. 1, 2, 3, 4. And at 3, we're at 9. So it's a curve that looks like this. Okay, that's what we get from using those dots. We've graphed the curve. What are the initial and terminal points? Oops, I forgot this part. The textbook says they want t to be greater than or equal to 0. Okay, so the initial point would be at t equals 0. A terminal point would be if t stopped, like if it was t is greater than or equal to 0 but less than or equal to 10. Then t equals 10 would be the terminal point. There's an initial point but no terminal point. The initial point's when t equals 0. And when we plugged in t equals 0, we got 0, 0. That's it. That's all they want for the initial point, where it starts. Okay. And then we need to find a Cartesian equation. So all you have to do is substitute y in for t into the other equation. Plug y in here. So y, oh sorry, for t, not for x. Plug y right in here. So if you do that, you get x equals the square root of y. Okay. And then they say what portions of the graph of the Cartesian equation is traced by the parameterized curve. So sometimes when you make that substitution, you lose some of the parameterized curve. Okay. Let me see. How could we possibly lose something? I think we're good. I don't think we lose any part of the parameterized curve here. Because if you were to graph this, x equals square root of y, it should be the same thing. I'm trying to think of it here. Maybe I can come up with another example. I'll do another video where we have one where we don't have the same curve.